All right, so we're really getting into some powerful tools in chemistry, and the tools we're going to consider in TRO Chapter 3, Section 3 is chemical formulas, are really representing compounds, right? Because we don't want to have to draw out every little detail of every compound as we go along. Sometimes we're going to want a shortcut, of course, and we're going to want to be able to use models that pack a lot of information with as little effort as possible. And so this is a very big deal chapter. Love it. Chemical formulas and molecular models. So first of all, let's consider empirical formulas. Now, a definition of empirical formulas is going to be only so good until you get a chance to really wrestle with it a little bit. The empirical formula is the formula as a ratio of the atoms in the molecule. And here below I've got a hydrocarbon molecules, 3 hydrocarbon molecules, and the ratio is x to y. So it's going to be x to y as a ratio, but it's important to understand that we're going to be writing the x and y as such, okay? So what is the ratio of x to y in cyclopentane? So it looks like here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10. And here I've got 1, 2, 3, 4, 5, okay? So it looks like this ratio goes to 1 to 2. Okay, so the empirical formula for cyclopentane is going to be C1H2. And it's important to appreciate that when we have a 1 here, we're going to simply write this as C. And if there's nothing there, we're going to imply it's a 1, CH2. So that's the empirical formula for cyclopentane. Now let's look at the empirical formula for cyclohexane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've got room to write here. 1, 2, 3, 4, 5, 6. Okay, 6 to 12. And it looks like we are at 1 to 2 again, right? So the empirical formula for cyclohexane is also CH2. Okay, well, let's do another one. 1, 2, 3, 4. 1, 2. Oh my. Okay, so it looks like the empirical formula for ethylene is also CH2. All right, so you might say, well, what value is the empirical formula then? Well, there's a couple values we have, and most of them I think you'll have to appreciate later after we've learned more chemistry. But for now, the empirical formula simply gives us the ratio of the atoms in the molecule as they're given. Okay, so if it's a hydrocarbon, then it's going to be CXHY, right? So this does tell us something. It tells us we have twice as many hydrogens in there as we have carbons. Okay, so not a lot of information, but it's something. And we'll find later that we do use the empirical formula sometimes to great value. Okay, so the next formula I want to consider is the molecular formula. Now, the molecular formula is the actual number of atoms in the molecule actual number CXHY, right? So the actual number, we counted those in the previous page. If you don't mind, I'm just going to go ahead and remember what they are. It's C5H10. Can you see if I reduce those numbers, it would be CH2? Okay, but that would be CH2 is the empirical formula for cyclopentane, and C5H10 is the molecular formula for cyclopentane. Cyclohexane, forgot to get my sheet out here. Cyclohexane is, where am I here? Lost my place. C6H12, right? So it looks like they have different molecular formulas, but the same empirical formulas these three do. C2, I can see it by looking at it, C2H4, right? So these three have different molecular formulas, but the same empirical formula. So the molecular formula, again, is the actual number of the atoms in the molecule CXHY. Okay, now what about a structural formula? The structural formula gives more information yet. It not only says how many are there, but it shows how they're connected. Okay? So an example, I'll give you an example in a moment of something I might have used for this, but for now, the structural formula, well, this is the structural formula, right? So not only do we know its empirical formula, we know the ratio of carbons to hydrogens, but we also know its molecular formula, we know how many there are, right? But here, we know how they're connected. They're connected like that, right? I don't need to draw this whole thing out. You've got it right here. It's right here, but you can see how they're connected. Agreed? So here, the empirical formula is CH2. The molecular formula is C6H12. And the structural formula is here. Right? Empirical formula here, CH2. Molecular formula, C2H4. And its structural formula is as you see. All right. So, in review, empirical formulas list the relative number of atoms and of atoms of each element in each compound, and molecular formulas list the actual number of atoms of each element in each compound, and structural formulas show how the atoms of each element. Wow, man, I need to proofread my stuff, don't I? Shows how the atoms of each element are connected or bonded to each other. Okay. So, let's look at any example. Write the empirical formula for the compounds represented by the molecular formulas, okay? So we've got the molecular formulas here, and I'm going to write this as CXHY, C4H8, and the ratio is, I'm going to reduce like this. I'm going to put the smaller one on top, always put the smaller one on top, and the ratio is 4 to 8. Go to the lowest, to the smallest whole numbers, 1 to 2, and so it looks like this is C1H2 or CH2. There's my answer. Okay, let's do the empirical formula for borane, B2H6. I'm going to write this as BXHY, X over Y, right? I'm choosing the smaller one to go on top. It's 2 and 6. Can you see what these reduces to? 1/3. And so it looks like it's going to be B1H3 or BH3 is the empirical formula, right? Here's the molecular formula. Just circle the molecular formula, square around the empirical formula. Write the empirical formulas, which is square, from the molecular formula, circles, okay? Let's do another one. CCl4. So this looks like CXClY, and X over Y is equal to 1 over 4. That doesn't reduce to anything, all right? It's already reduced. So it looks like this is going to be, just a second here, C1, CL4. Oops, that's what I already have up there, right? CCl4. Sorry, my handwriting is getting messy here. It looks like that is already the empirical formula. So in this case, the molecular formula is the empirical formula, and it's because these guys don't reduce any further. Okay, so finally let's look at a few ways to look at molecules. First of all, one way to look at molecules is to simply give it its name. Sometimes we don't really want to draw out the formula. It sort of depends on your conversation. It might not matter what the formula is, right? So we might use benzene, just the name. Name? What is this? What is CH? If this is the formula for CH, or this is the structure of benzene, what would you call this? This is the empirical formula, right? And this is the molecular formula. Can you see that? And this is the structural formula. We're going to call this ball and stick, it doesn't matter what you call it, of course, but usually if you hear ball and stick, that's what this is. It's not going to be something you'd be drawing a whole lot because that'd be take a lot of effort. You can draw a structural formula, but it's hard to draw a ball and stick, but you might, in the textbook can draw it for you, or we can draw it with a computer program. And this is oftentimes called space filling. Okay, the reason we do space filling is because it turns out these atoms really do have a lot of electrons around them, and so if we could consider the actual space that a benzene molecule takes up, it would look more like that, right? Of course, it's not going to be black and white because these atoms are smaller than color, but it would be more like that. Okay, acetylene is the name of this compound here. Its empirical formula is still CH. Wow, just like benzene. Wow, and they're very different, aren't they? Its molecular formula, though, is C2H2. Okay, so that's what we got here. It's a triple bond between the two. We'll describe later why. Ball and stick molecule will show the relative, different size of those guys. Probably not drawn to scale. Here's one that's a little more drawn to scale. Turns out carbon's a good bit bigger than the hydrogens on the end. And here's a space filling model of that. And you see the same thing for glucose here, where the empirical formula, there are 2 atoms of hydrogen for every 1 atom of carbon and oxygen. But the actual number of atoms in there is here, C6H12O6. And here's how they're connected, right? This is the structural formula. Slow down. Structural formula tells us how they're connected, right? Ball and stick gives us some sense of what they look like. And space filling, wow, you can see with space filling, we end up giving so much information that we end up losing information with space filling because it's hard to see how things are connected there. Okay, hope